All right, welcome back to the second video. This is chapter 1.2, and we have our three questions here and then our summary and our question. So for number one, it says B is the midpoint of segment AC. AB is equal to 5x, and BC is equal to 3x plus 4. And you want to find AB, BC, and AC. So the first thing we can do is draw our segment AC. So if we go ahead and draw this, I'm going to call that C, and we can call that A. Then the next piece of information it gives us is that the midpoint is B. And one of the things that we have to continually go back to is our vocab. And midpoint means it's exactly halfway. So we can go ahead and put that there. And then to make sure that both of these are the same exact length, we can go ahead and draw these little tick marks just to visually show that these things are the same length. So now they give us the next piece of information. AB is 5x. So we can go ahead and put 5x here. And segment BC is 3x plus 4. Find AB, BC, and AC. So at this point, we're given our information, and now we have to use a little bit of algebra. So since we know that 5x and 3x plus 4 are the same length, we can actually go ahead and set those equal to each other. And now we use algebra to solve. So in this case, we want to get all of our variables on the same side. So I'm going to go ahead and subtract 3x, and we get that 2x is equal to 4. Now, to solve from here, we can divide, and I'll go ahead and put this over here. I'll do it in yellow. So 2x is equal to 4. I'm going to divide both sides by 2, and I get that x is equal to 2. Now, we want to find AB, BC, and AC, so the lengths of all of those. So what we want to do is plug in x equals 2 in for our x in 5x and for 3x plus 4. So if we go ahead and go here on the right, I'll do this in green. The line AB, so AB is 5x. Well, now we have, sorry about that. We have 5 times 2, which in this case is equal to 10. BC is 3x plus 4. So now if we plug 2 in for x, we get, let me erase that quick. We get 3 times 2 plus 4, which is also equal to 10. And you want to go ahead and just check both of those. For this, it's a little bit simpler to be able just to see it, but it is nice to check both of them to make sure. And then line AC, since we know that AC is made up of segment AB and BC, we know that 10 plus 10 is 20. So that's question number one. For question number 2, it says, on a subway route, station C is located at the midpoint between stations A and D. So what we can go ahead and do is draw our line again. So we have points on both sides. Let's see, and that's A and D. And we know that C is the midpoint, so we can go ahead and put those in the middle. And then again, we can go ahead and put our tick marks to show that they're the exact same length. Then it says station B is located at the midpoint between stations A and C. So we know it's halfway in between A and C, so I'm going to go ahead and put B right there. And then to show that these are the same, I'm going to go ahead and put 2 tick marks, just because they're different than segment CD. So we want to make sure we differentiate those. If the distance between stations A and D is 2.4 kilometers, so I'm going to go ahead and draw that in. So if this whole thing is 2.4 kilometers, what is the distance between stations B and D? Hint, draw a picture. And drawing a picture really does help, so you want to make sure you can do that. So if we look at this, we know that this whole thing from A to D is 2.4, and we know that C is the midpoint, so it's exactly halfway. So we know that from C to D, we are going to have a distance of 1.2 kilometers. And then we know from A to C is also going to be 1.2 kilometers. And then if we look at A to B and segment B to C, we know those are exactly the same. So if we split those in half, we know that each of these is going to be 0.6 because 0.6 plus 0.6 equals 1.2. And we know that A to C is also 1.2. So if we know all of the distances here, which is what you want to do to tackle these questions, now we can go ahead and see what they're asking for. So what is the distance between stations B and D? So if we look, B to C is 0.6. So I can go ahead and put that here. And from C to D, it's 1.2. So if we add 0.6 plus 1.2, we get 1.8 kilometers. And that's what we're looking for. For number 3, it says find TV. So in this case, we're going to follow a similar pattern, but this time they don't give us as many numbers. So what we're going to have to do is set up an algebraic equation and solve. So we know from S to T is 20, and we know from T to V is N, and we know the total from S to V is 2N minus 1. So what we can do is go ahead and set that all up together. So 20 plus N is equal to 2N minus 1. Now we can go ahead and solve those or solve this equation for N. So in this case, I first like to get all my variables on the same side. So I'm going to go ahead and subtract N from both sides. And that gives me 20 equals N minus 1. Then I want to get all of my numbers on the same side. So I'm going to go ahead and add 1 to both sides. And I get that 21 is equal to N. So I went into my summary, but that's okay. So 21 is equal to N. And if we look what we're looking for TV. And we also see that TV is the same as N. So we can just say TV is equal to 21. Now in this last one, number 4, it says draw the difference between a bisector and a perpendicular bisector. Now this is, again, goes right back to the vocab. In a bisector, what a bisector does is it splits something in half. So if we were to draw, I'm just going to go B for bisector. And then over here, I'll do PB for perpendicular bisector. So this first one, a bisector, if we were to draw a line from here to here, and we have a midpoint where both of these sides are the same, and then we draw a line that bisects this, we could draw this line right here. And again, it's not quite perfect, but it splits this line in half perfectly so that we have the same on the left and on the right. Now, if we were to draw that same line on the right under perpendicular bisector, the only difference here is that a perpendicular bisector has to bisect the line at a right angle or at 90 degrees. That's what perpendicular means. So what we can do here, and I'm going to draw right through the PB, is a line that goes right here. And we can draw a right angle because that bisects that at a 90 degree angle. So go ahead and jot down your quick summary, jot down your questions that you may have. Maybe, again, you don't get an example here, so you could say example number 3, right? Or something like that. And we can go over it in a later video. Okay, have a great night, and we'll see you.